Hello students, welcome to Target IES. I hope you are having a wonderful day. Let us continue with module number 5 of our RCC. I hope this topic is very simple for you, right? मजा आ रहा है ना? काफी simple दिख रहा है ना? No need to worry at all. So let us continue with this module and finish the first chapter in this module. Hardly it will take 10 minutes, but I might be dragging it to 15 or 20 minutes. I will be teaching some important points like that, okay? So while studying this topic you should be aware of few things. Okay, in the last module I have started the concept of reinforcement. I have told you the concrete whatever we have, it is very good in taking compression, but it cannot take what? Tension. Concrete is poor in tension. So obviously whenever you are loading आपको tensile forces भी आएंगे, compressive forces भी आएंगे. So whenever we have tensile forces, concrete cannot take it. That's why what we are doing is, in concrete we are introducing some reinforcement. This reinforcement can be steel, or it can be aluminum, it can be anything, it can be copper. If you want, if you are rich, you can make it with gold. It doesn't matter, आपको जो चाहिए वो रख लेना, which has good compressive as well as tensile force taking capacity. Basically tensile force चाहिए, so whatever is capable of taking tensile force you can use that. Okay, अगर आपको bamboo use करना है, bamboo भी use कर लेना, कोई problem नहीं. You can use anything which is good at taking tension as your reinforcement. But after seeing all the pluses and minus, we go with steel. Okay, why? Because it is economical also, it has very good strength, high tensile strength, and excellent thing is it has very close coefficient of thermal expansion as that of concrete. So whenever they are expanding or contracting, आपको क्या हो जाएगा, कोई frictional stresses नहीं develop होंगे, because both my steel and concrete will be elongating almost by the same amount, contracting by the same amount. I hope you're getting it right. And next I have taught you size of reinforcement. See, we don't have different sizes of steel. Like we will not get, like if you want 5 mm size steel bar, you will not get it. Okay, 4 mm nahi milega aapko. There are some standards, only these size are available, like 6 mm, 8 mm, 10 mm, 12 mm, 16 mm, 20 mm, 22, 25, 28, 30, up to 50 you will be having like that. But there are few very important things which you have to remember, like 6, 8, 10, 12, 16, 20, 25, 32. इतने तो आपको याद रखना ही पड़ेगा, because these are frequently used in our construction. ठीक है, I hope you will remember this. And अगर आपको याद रखना है, see sometimes what happens is, how to find area of the 6 diameter bar. ये जो 6 diameter का bar है, area of cross section इसका कितना है? That will be pi by 4 into d square, pi by 4 into 6 square. So it might be difficult for you to calculate every time in examinations, especially like ESC, where time plays a very crucial role and you don't have calculator. For that purpose you can remember this approx areas, but I don't suggest you to remember यार, इतना भी जरूरत नहीं है. What you can remember is for 10 mm and for 16 mm. 10 mm का कितना है? 75 अप्रॉक्स आएगा एरिया, पाई बाय 4 डी स्क्वायर कर लोगे, इट इज अराउंड 78.54. You can remember it as 75. And if you are doing pi by 4 into 16 square, you will be getting somewhere around 201.06. You can take it as 200. ये दो याद रख लेना बस है. Okay, so I don't encourage to remember or by heart anything. जो भी है दिल से पढ़ना है. ओके, ऐसे न्यूमेरिकल्स बाय हार्ट करने से आपका गेट या ईएससी क्लियर नहीं होने वाला है. So I hope it is very clear for you. So I have given a small example also, calculation not at all a problem. You can keep in whatever configuration you want. You just have to reach whatever steel area is required, उतना आपको provide करना है. It doesn't matter you are providing 12 mm के 5 बार आप provide कर रहे हो या 20 mm के 3 ही बार provide कर रहे हो. It doesn't matter, you can do it. Okay, but there are some specifications based on what you can decide. We'll study later on. हल्का धीरे धीरे हम पढ़ाई करेंगे. Just give me a second. I'm getting a phone call. Let me pause this. Yeah, let us resume. See, what are the various types of steel bars we use? Okay, what are the various grades of steel we actually have? So you already know the mild steel, right? Mild steel आप जानते ही है, right? पढ़ा होगा. So this mild steel is represented by Fe250. Fe250. Why 250? Because yield stress in your mild steel bars, whatever it is, right, it is around 250. That's why we are representing it as Fe250. 250 represents your yield stress of your mild steel bars. I hope it is very clear, right? So similarly we have some high yield strength wale deformed bars. Okay, high yield strength deformed bars, HYSD. See, this is exactly same as mild steel. Then why we are getting higher stress, higher yield stress क्यों आ रहा है 415 500 क्यों आ रहा है? Because even though it is chemically exactly same as mild steel, the manufacturing process is little bit difficult. Whenever you are manufacturing it, whenever you are heating it at 1400 degrees centigrade, right? So after cooling to about 200 degrees centigrade, what we do is the steel bars whatever we have, we elongate it. ठीक है? What I am doing, I am elongating the steel bars and I am twisting it. Okay, whenever I am twisting it, there will be some this type of concussions formed on your steel. Agreed or not? So now this bar I am calling it as high yield strength deformed bars. You have deformed it, right? आपने twist किया हुआ है. You are twisting your steel bar. You are elongating, stretching, and you are twisting the steel bar. Because of this, what is happening? You are getting higher strength. Okay, you are getting higher strength, and this classification we are calling it as HYSD, high yield strength deformed bars. So we have recent developments also like FE500D. D stands for ductility. See, the problem with this is the higher grade whatever we have, right? So they are little bit brittle. Ductility क्या रहती है? थोड़ी कम रहती है compared to your mild steel. As you are changing its manufacturing process, right? आप elongate कर रहे हो, आप twist कर रहे हो, so ductility will be little bit less. To adjust the ductility to normal, we also have a bar which is called as FE500D, where D stands for ductility. Obviously it will have higher ductility compared to our FE500. Okay, we have FE550 600 also, but हम जनरली कौन सा यूज करते हैं? एनी वन ऑफ दिस 415 और 500 इन आवर कंस्ट्रक्शन मोस्टली. FE250 का भी हम यूज करते हैं. आई होप इट इज वेरी क्लियर फॉर यू. एंड दिस स्टील का स्ट्रेस एंड स्ट्रेन डायग्राम, दिस इज लाइक वन ऑफ द मोस्ट फेमस डायग्राम्स, राइट? everyone knows this. स्टील में पढ़ा है, सॉम में पढ़ा है, एंड आरसीसी में भी आएगा. नॉट एट ऑल अ बिग प्रॉब्लम, एंड यू ऑलरेडी नो दिस टेबल, ऑलरेडी यू नो दिस ग्राफ. So when this graph whatever you have, right, stress versus strain, if you have something falling like this, right, obviously it is always by controlled stress method or controlled strain method. Controlled strain method, controlled strain method पढ़ाया था ना फर्स्ट मॉड्यूल में. controlled strain method, because if you are controlling the stress method, only control stress method जो भी है, आपको ये फॉलिंग वाला पार्ट नहीं आएगा. इन दिस कंट्रोल स्ट्रेन मेथड व्हाट यू आर डूइंग, यू आर गिविंग द स्ट्रेन. ओके, यू आर इंक्रीजिंग द स्ट्रेन एंड मेजरिंग करस्पॉन्डिंग स्ट्रेस. दैट्स व्हाई यू आर गेटिंग दिस शेप. द फॉलिंग वाला का इसीलिए आएगा. इफ यू आर डूइंग ओनली कंट्रोल स्ट्रेस मेथड, यू वोंट बी गेटिंग फॉलिंग वाला का. आई होप इट इज वेरी क्लियर फॉर यू, right? So now let us continue with these bars. First one is mild steel bar, which you already know. Now let us see this HYSD bar. HYSD bar के दूसरे भी classifications like CTD, TO और CTD यानी cold twisted deformed bars. But we study only one year. HYSD ही पढ़ाई करते हैं, high yield strength deformed bars. So what is the concept? So the chemical properties of HYSD and mild steel are one and the same, but method of manufacturing is little bit different. How? Because once mild steel in manufacturing process itself 1400 degrees से cool किया जाता है, but not at room temperature, at 200 degrees centigrade. At this temperature, what we are doing, we are pulling and twisting my steel bars to get my HYSD, high yield strength deformed bars. Okay, so this is your stress strain curve for your mild steel, right? कुछ इस तरह से रहेगा. So here you will be having proportionality limit, here you will be having your yield stress, lower yield stress, and then plastic state. Again you will be having strain hardening. उसके बाद क्या हो जाएगा? You will be getting into neckling zone, and finally आपका crack हो जाएगा, right? You might have remembering this curve. But what you are doing is, whenever you are manufacturing this high yield strength deformed bars, what we are doing is, here in this zone, whenever you are dragging this, you are changing its orientation, you are pulling and twisting it, so you are getting an higher strength. It is noted that we are getting some higher stress. If I am drawing it separately here, मेरा HYSD का कुछ इस तरह से कर्व बनेगा, कुछ इस तरह से कर्व बनेगा. Okay, with respect to stress and strain, I am getting this type of diagram. See the problem with HYSD bars is it can take lot of stress, right? It can take lot of stress, but you have to understand the strain is also increasing, right? क्या हो रहा है? The strain is also increasing, so the deformation will be very large. A structure might not collapse, but what is happening? You are having large deformations, structural change हो जा रहा है. See, that's why we won't be allowing that much amount of strain. The maximum strain actually we keep around is 0.2%. ठीक है, 0.2% के पास हम मैक्सिमम स्ट्रेस कंसिडर करते हैं. एंड दिस वॉट एवर आई एम कॉलिंग, राइट, दिस 0.2% करस्पॉन्डिंग स्ट्रेस, that Fi value whatever I have as my proof stress. So that is the stress beyond which up to which there won't be any huge change in my structure of my steel. I hope you are getting it right. So this value of stress corresponding to 0.2% of strain, I am calling it as proof stress. I hope you got it. Concept is very clear. Actually, if you want to strain it further, it's perfectly fine. You can clearly see, just give me a second. If you are even if you are even increasing your strain values, your stress values is constantly increasing. But if you are taking this much strain, it won't be good for your structure. ठीक है, permanent deformation हो सकता है. So I am considering a strain at 0.2% as a limit, and the stress corresponding to that I am calling it as proof stress. I hope concept is very clear for you. समझ में आ गया? It is obtained. How you are getting this HYST, as I have explained you earlier, it is obtained out by straining mild steel beyond yield plateau by stretching and twisting at particular temperature. What is the particular temperature? 200 degrees centigrade. And after that it is unloaded. Once you are stretching it, okay, obviously you are applying certain force, right? You are applying certain force at 200 degrees centigrade, and then you are twisting this bar, and once you have twisted, you will be unloading. ये जो load आपने apply किया है, that will be removed. Okay, I hope you got it. So above process of straining, whatever you are straining, right, it will eliminate the yield plateau from stress strain diagram. So you can clearly see यहाँ पे yield plateau नहीं है आपको. HYSD, you doesn't have any yield plateau. You directly have only curve like this. But in mild steel, you have this yield wala plateau. Here you don't have any yield plateau. Because of this training, that yield plateau is gone. I hope concept is clear for you. And you have to remember that HYSD is less ductile than mild steel. Right? HYSD is less ductile than mild steel. That's why recently what started to come, FE 500D bars have started to come. Okay, but आज भी हम कंस्ट्रक्शन में FE 415 FE 500D मैक्सिमम यूज करते हैं. In the absence of definite yield point, what is the yield point we are considering? We are considering stress corresponding to 0.2% of strain. So that is called as proof stress. I hope you got it. Everything is clear for you. Next, we also have some developments over HYSD bars. I told you HYSD bars are little bit brittle, right? Ductility क्या हो रहा है? कम रहा है. Ductility is little bit less. So we have one more bar which is called as TMT bar. आपने ad में सुना होगा ना, advertisement, right? So whenever in TV there are some ads coming, so TMT bars खरीदिएगा. So Lakshmi TMT bars, some Devi TMT bars, like this the ads will be coming up in your TV shows, right? So these TMT bars, what they are? They stand for thermomechanically treated bar. So this full form is also very important. In small examinations you can ask it. Okay, so what is TMT? Thermomechanically treated bars. So basically in these bars we will be having three sections. One is inner section. Inner section क्या रहता है? It will be little bit soft. Inner section is soft. Therefore the ductility will be high in this inner section. ये जो middle वाला section रहता है, this middle wala section, let me change the color, this blue color, the inner section wala part. So this is very hard and it will be responsible for strength. Okay, the middle part is very hard and it will be responsible for strength. Inner part, whatever we have, it is soft and it will be responsible for your ductility. Over that we will be having one small layer. ठीक है, एक coating type एक layer रहेगा, and this layer will be such that it will give you corrosion resistance to your steel bars. Steel bars का corrosion काफी जल्दी हो सकता है. That's why providing this cover will obviously increase the life of your steel bars. So this configuration of outer corrosion resistance layer, inner में क्या बोलता है, high strength वाला bar, and inner soft whatever we have giving ductility, this combination of steel bars we are calling it as TMT bars. Okay, these bars are produced by thermal and mechanical process simultaneously. These combination of process makes steel relatively more corrosion resistant. Okay, TMT bars are more ductile compared to HYSD bars. Why? Obviously because they have inner soft layer which is providing ductility to it. TMT bars have relevant features of HYSD bars. Okay, so ductility is increased and remaining all good features of HYSD bars are present in my TMT bars. So this concludes type of steel parts. Now let us see a very important note. ठीक है, whenever you are manufacturing this steel, if you have the carbon in it, if you have carbon content in it, it increases your strength. Okay, ultimate stress क्या होता है, increase होता है, but we have a downfall. Our ductility of steel will decrease. Okay, it will start to become brittle. So we have one problem here. Okay, we have advantage of higher strength, but ductility is decreasing, so it should be in fixed limits. Ultimate stress of larger diameter bar is less as compared to that of lower diameter bar. This is very similar to that of the concrete cubes, whatever I have taught you, right? Same concept chal raha hai. If you have two bars, let us take one diameter, higher diameter D1 and area corresponding is A1, load applied is let us say P1. There is one more bar, this area is A2 and load applied is P2, right? So the ultimate stress of larger diameter bar is less than that of lower bar. So the ultimate stress whatever you are getting P1 by A1 जो भी बन रहा है, right? So it will be less compared to P2 by A2. ठीक है, so the lower diameter bars have more capacity, okay, more ultimate stress wala capacity. Even though the load can be less, the P2 will be less than P1, but compared to the stress, the load divided by area, that capacity will be more for my smaller diameter bars. I hope it is very clear, right? So this concludes the chapter, but before rushing out and before stopping this video, I have one concept left, which is called as what, which is workability of concrete, if I am not wrong. So just let us have a look of that also. Not important, I know you all civil engineers, you might have already studied it in your building materials, but एक बार रिवर्स करने में क्या जा रहा है. See what are the various tests we have for this workability. We have slump test, we have compaction factor test, we have VV compactometer and so many other tests, right? So first one is slump test. So slump test में क्या रहेगा, there will be a cone like this. So नीचे का diameter कितना 20 mm, ऊपर का diameter 10 mm, sorry, नीचे का diameter 20 सेंटीमीटर, ऊपर का diameter 10 सेंटीमीटर and the height is 30 centimeter. In mm you can remember it as 300, 200 and 10. So we'll be like compacting the concrete in 3 to 4 layers. After that what I will be do, I will be lifting this cone. ये जो steel का cone है, I will be lifting it. As soon as I am lifting it, right, so what you'll be having, you will be having a slump. Okay, so you will be having a slump, right? वैसे ही fix नहीं हो जाएगा ना, it is a fresh concrete. So if you are giving time and allow it to set like that only in the cube, even if you are removing the steel cube, वो ऐसे ही रहेगा. But this is a fresh concrete, it has a property of workability. So whenever you are taking out the support of the structure, whatever it is supporting, so what will happen, some of the concrete will fall down, कुछ इस तरह से fall down हो जाएगा, the नया structure कुछ इस तरह से रहेगा, right? So the decrease in height we are calling it as slump, right? So this slump will give us a rough idea of workability. If slump is more, okay, अगर concrete कुछ ज़्यादा ही slump बता रहा है, okay, so let us try to understand. If our slump is more, that means workability is more, वो easy से flow हो रहा है, the concrete whatever you have, it is easily flowing, that's why the slump is more. If the slump is less, that means it is a very rigid concrete, workability is very less, okay, the ease with which it can move is very less, that's why it is in a fixed position. So that was about your slump test. Next आके आपका compaction compacting factor test है. यहाँ पे क्या रहेगा, you will be having operator something like this. Okay, so यहाँ पे क्या करोगे, this let us take this as my vessel 1 and this is my vessel 2. So what I basically do is I will take some concrete and fill my vessel 1. ठीक है, I will fill my vessel 1 completely, compact कर दूंगा, the volume will be same, the volume will be same. So what I will do is I will release, यहाँ पे एक जो pin रहेगा holding the plate, I will release the plate. Now what will happen, all the concrete which was filled here, right, it will be falling here. Let the weight of this is W1. If the concrete is workable, most of the concrete what will happen, it will go and fall here because it has easiness to move, right? So it will go and fill this box, so you will be getting more amount of concrete here. But let us say if the concrete is little bit rigid, it doesn't have that much workability, so all concrete will not be going and collecting in this vessel, that is not practical, only some will be getting collected, so the weight which is collected of this concrete will be less. That means less workable concrete and less workable concrete. I hope you are getting it right. Very simple concept. If concrete whatever you are getting in the second cooper is more, then the workability is more. If the weight of the concrete whatever is collected in this whatever uh, Cooper you have, right? If it is less, that means the workability is also less. So how to get the workability? You can get just w2 by w1, right? But what you can do, you can subtract the weight of this jars also. That will be very convenient. So w2 minus w1, w2 माइनस डब्ल्यू नॉट डिवाइड बाई w1 माइनस डब्ल्यू नॉट कर लेना. आपको क्या आ जाएगा? आपको आपका कॉम्पैक्शन फैक्टर आ जाएगा. एंड दिस कॉम्पैक्शन फैक्टर ऑब्वियसली इट विल बी मैक्सिमम इक्वल्स टू 1, बिकॉज उससे ज्यादा कॉन्क्रीट तो नहीं आएगा, राइट? सो मैक्सिमम इट कैन बी इक्वल्स टू 1, बट बेस्ड ऑन योर वर्कबिलिटी इट विल बी जनरली लेस देन 1. So this is about compaction factor test. Very simple test, right? And next we have VB test. In VB test, what we do is, see, if the concrete is very rigid, obviously most of the concrete is not going and falling in my second cooper, right? Or if you are doing the slump test अगर आप कर रहे हो, it is not showing any slump even after removing the cone, so your concrete looks almost same. So for this concretes what we have this VB test. So here what I'm doing is same जो slump वाला रहेगा. So similar cone we have lifting this cone, and the concrete whatever we have, right, on this circular transparent glass disc will be kept. A circular transparent glass disc will be kept, and here I'm vibrating this whatever rectangular jar we have up to the shape. Whatever this cone is there, right, it will be changing and taking the size of my surrounding shape, which is rectangle or circular, whatever it is. Okay, I hope you got it right. So this is the test. What I'm doing, I'm just closing it at the top with the lid and I'm shaking it, I'm vibrating it. Okay, when I'm vibrating it, obviously it will lose its shape and taking the shape of this whatever surrounding cone you have. Okay, if it is a circle, it will be taking the shape of circle, as simple as that. So what we have to do is we have to measure the time duration in which it is changing its shape from this cone to your circular disc wala shape, whatever shape you want. So you just have to measure the time, and this time will give you your VB test. Okay, if the time is less, that means it is more workable. Agar aap thoda vibrate kar rahe ho, it is taking the shape of this container, then it is more workable. If it is taking more time, even after shaking it is taking more time to settle down slowly, then obviously it is less workable. Like that you can understand the concept, right? I hope it is very simple for you, not at all a problem. So I have given a table which you have to memorize. Very important for small examinations. Very important for small examinations. Degree of workability, there are again 5 types. One is very low, medium, high, and very high workability. Very low workability means it is almost very rigid, it is not easily flowing. Very high workability, it is like water, almost it is flowing very easily. Okay, so very high workability has very huge ease of motion of my concrete, freshly mixed concrete. Okay, so if the concrete is having very low workability, then it will be used in what? It will be used in roadworks. If it has low workability, then it will be used in mass concreting, shallow section, light reinforcement sections में हम use करते हैं. If it has medium workability, then you can use it in heavy reinforcement structures and concreting for from concrete pump you can basically use this. If you have high workability, okay, if it is like flowing like liquid, थोड़ा बहुत workability ज़्यादा है, ease of motion is more, then you can use it for pile foundation. And if it is very highly workable, okay, extremely high is it is moving, then we can use it for trimmy pile concreting. What is trimmy pile concreting? Basically underwater concreting hota hai. So here what you will be doing is you will be having a cooper up to one foundation, and here you will be start doing your concreting work. Concrete pour karoge and यहाँ पे आपका concrete rock बन जाएगा. So this was your trimmy pile concreting. Okay, so for trimmy pile concreting we need very high workable cement concrete. So this is a very important bit which you have to remember. trimmy pile concreting के लिए कौन सा workability चाहिए? Very high workability चाहिए. Okay, so like this bits can come. And what is the slump corresponding to this test is also important. If it is low workable test, generally slump will be 25 to 75 mm. If it is medium workability, then slump will be 50 to 100 mm. If it is high workability, 100 to 150 mm. Very important. And for compaction factor, if it is very low workability, 0.75 to 0.8, which is my W2 divided by W1. So if it is low workability, 0.8 to 0.75. If it is medium workability, 0.85 to 0.92. If it is high workability, 0.92 and greater than. And very high workability it is hard to say, हम almost same ही लेते हैं 0.92 and greater than, it could be any one of high workability or very high workability. And we have VB test. I have told you VB test, if it is falling in very quick time, if it is changing shape in very quick time, then obviously it is having a better workability. So if it is for very high workability, we cannot actually do it because ये तो shape ही form नहीं हो रहा है ना. As soon as you are lifting it, it will be taking the shape of your container. So for very high workability you won't be getting it, for high workability also you won't be getting it. For medium workability it is 3 to 5 seconds, for low workability it is 5 to 10 seconds, and very low workability 10 to 20 seconds. ये table भी आपको थोड़ा बहुत important है, but it doesn't comes under RCC. This is not RCC part, it is building materials part. In building materials I have already taught this table. I hope you remember it right, गलती नहीं करोगे. So even if you forget, no issues, you can revise it right now. And for slump cone, if it is very low workability, even if you are removing the cone, it will be having same shape, so you cannot measure the slump, right? So you generally don't perform it for a very low workable concrete, and as well as very high workable concrete. If the concrete workability is very high, if you are removing the cone, obviously it will be falling down, right? Slump कुछ measure ही नहीं कर पाओगे. So obviously very high workability and very low workability you cannot do with your slump test. So I hope you are perfect so far. So this concludes your chapter number 1. What we can do is we can see some of the important bits, or I will tell you what you have to read. Okay, at least मैं क्या कर दूंगा, I will teach you what you have to read, and please read it. Okay, so what about the size of aggregates? And I have already highlighted it in IES 456 soft copy which I have given you. So just read this. Okay, so size of aggregates का एक size है, you cannot exceed that. So everything whatever highlighted, right, you have to be perfect in that. And coming to the water, whatever water it is good for human body is also good for mixing concrete. Okay, if you are able to drink that water, you can use it for mixing of concrete, but there are some specifications. The pH value of water, it cannot be less than 6. This was asked in more than 10 examinations, more than 10 exams this bit came. The pH value of water should not be less than 6, so it should be always greater than 6 only. And you cannot use sea water. Of course, अगर सी वाटर के सिवा आपके पास कोई वाटर नहीं है, इन दैट केस ऑब्वियसली यू हैव टू यूज सी वाटर. अनफॉर्चुनेटली उसमें रीइंफोर्समेंट नहीं रहना चाहिए. इफ यू हैव रीइंफोर्समेंट बार, स्टील बार्स, सी वाटर कैनॉट बी यूज्ड. फॉर प्लेन सीमेंट कंक्रीट, in the worst case, if you don't have any further water, then you can go for sea water. Okay, and we have very one important specification. Read this specification. Average 28 days compressive strength of at least 3 150 mm concrete cubes. Okay, 28 strength of 150 mm concrete cubes, whatever you have made with this water available to you, right? So it shall not be less than, the strength of this cube should not be less than 90% of strength of the similar concrete cubes which are manufactured with distilled water. So use distilled water and cast some cubes, and the strength of the cubes whatever you got using this water, the water available in that location, it should not be less than 90% of strength of this concrete. I hope you got it. Very important bit, right? And we also have limits, permissible limits of water. What is, just give me a second. So it's already 30 minutes, right? So I will go very quickly, I will end it in couple of minutes. So this whatever we have, the different types of pollutants permissible in water, this is also very important bit for building materials, not for RCC, please do remember. So what is the permissible limits of solids? Organic solids in our water, it is 200 mg per liter. For inorganic, it can go up to 3000 mg per liter. Sulfates 400, chlorides 2000 mg per liter, and suspended matter is also 2000 mg per liter. Remember this. Okay, so inorganic, organic are very important. Organic 200, inorganic 3000. Bits maximum इसी में से आएगा. Suspended matter also can surprise you sometimes. So suspended matters, chloride, it is always 2000 mg per liter, and for surface it is 400 mg per liter. Okay, I hope it is very clear for you. And this chlorides whatever, right, it has actually two standards. One is 2000, which is for plain concrete, and maximum it can have is only 500 in steel embedded concrete, that is your RCC work. In RCC maximum 500 ही permissible रहता है, 500 mg per liter is only permissible. So similarly, what are the various bits we have, and what are the various grades of concrete we have? We have ordinary grade, which I have already taught you. M20 तक आपको ordinary grade रहेगा. From M25 to M55 we have standard grade. which we use what IES 10262, the design code. To mix this concrete, we have the design code and we have to use it. So if you have something higher, the design code is not mentioned. Based on experimental values, you have to use it. So M60 to M80, you can consider it as high strength concrete. You need not follow IS 10262 for this. Okay, I hope it is very clear for you. And coming to the shrinkage, what is the maximum shrinkage, approximate value of total shrinkage strain? How much is it? The shrinkage strain maximum value is 0.0003 or 3 into 10 to the power of minus 4 or 0.03%. I hope you remember this. And next is creep of concrete. So it is nothing but the time dependent strain value of your concrete. So if you are loading at early stages, okay, if you are loading at early stages, your creep value will be more. अगर 7 days पे ये load करते हो आप, okay, after casting cubes, after 7 days you are loading it, then creep value will be very high, almost 2.2 times ज़्यादा रहेगा compared to your initial creep value, initial strain value, right? If you are loading at 28 days, then 1.6, and after 1 year, if you are delaying the loading, then your creep coefficient will be very less. Okay, and there are some important points also here. Please read it once. What it depends on, like that rahega. And this is the same thing which we have just discussed. What is slump value, what is workability, everything I have just discussed, right? And what are the various factors affecting durability, and size and shape of member, how much it should be, everything is given here. So to this, please be perfect. Okay, and this table is very very perfect. I have taught you in detail, right? बहुत time लिया मैंने 20 मिनट explain किया था ये table, and I hope you will not forget it. For different exposure conditions, what is the grade of concrete we have to use, and what is the minimum cement content water cement ratio, and what is the minimum grade of concrete, you have to remember this. Okay, very important table hai. I hope you will not forget it. Now coming to the last topic, chlorides. See, chlorides is not that much good. Maximum, if you are using reinforced cement concrete, it cannot be greater than 500 mg per liter. Higher the chloride content, subsequent exposed to warm and moisture conditions, there will be greater risk of corrosion. Higher the chloride content, higher the risk of corrosion. ज़्यादा नहीं रहना चाहिए. Okay, and similar to that of sulfate. Sulfate is also not desirable. Sulfates, what is happening? Sulfates are present in most cements in the form of aggregates. Excess amount of water soluble sulfates agar rahega, then obviously it will definitely cause expansion and disruption to this concrete. Because of sulfate, what we are having expansion in this concrete, and obviously there will be dispersion. Total water soluble sulfate content of concrete mix as expressed as SO3, it should not be greater than 4% by mass of our cement in our mix. So he is saying this, whatever sulfates are there in the form of SO3, it should not exceed 4% mass of cement in my concrete mix. I hope it is very clear for you. And mix proportions, we have two mix proportion. One is nominal mix. If you are up to M20 or lower, right, you can use nominal mix. And I have already given you, right, 1:5:10, 1:4:8, 1:3:6, 1:1.5:3. So the standards we already have, we just have to mix and we'll be getting nominal mixed concrete. But design mixed concrete, we have some standard steps to follow. मैं करूँगा, but not important right now. First we have to understand the concepts of RCC. So RCC समझेंगे, design mix not that important. ESE में इसमें पूछ सकता है 20 marks के लिए, very rarely asked, but we will see that also. At the end we will see that also, right? So these are some important points which you have to remember from this chapter. In the next chapter I will teach you few more important things, but before that, write one thing: homologous temperature. What is homologous temperature? See, creep whatever we have, right, it becomes very high if temperature is increased. Okay, so creep ka jo bhi hai, it is increasing with temperature increase, but there is a temperature at which creeps becomes very 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 high. Okay, ये temperature को हम बुलाते हैं homologous temperature. Basically वो रहता है off of your melting point. Please make a note: homologous temperature is off of your melting point, and creep becomes very high if the temperature is raised to this homologous temperature. I hope you got it. सब कुछ समझ में आ गया. And one more thing you have to understand, why we are casting this 28 days. Why वी आर कास्टिंग अप टू दिस 28 days तक हम कहते हैं कि लोड मत करना, यू हैव टू टेक प्रॉपर केयर, यू हैव टू डू प्रॉपर क्यूरिंग, राइट? सो व्हाई सो? बिकॉज the cube whatever you are having, right, if you are measuring the strength at 7th day, only 70% of the strength will be there. If you are measuring M25 concrete, 70% of this 25 FCK only available to you, but at 28 day almost 99% is uptake. If you are delaying the strength, right, after you are measuring almost like 1 year, it will be almost equivalent to 100. Okay, with respect to time the strength will be gaining a bit, but ज़्यादा difference नहीं रहेगा. You see 28 days you are achieving 99% strength. So on 20 after 28 day you can usually use it for construction purpose. Okay, but if you want 100% strength then you have to wait even longer duration, which is not practical, right? आप कास्ट करके एक साल के बाद तो नहीं यूज करोगे, you will be using it instantly. So obviously 28 days we are taking it as standard because 99% of the strength is achieved by this 28th day. Okay, there are few more important things which I have highlighted from this chapter. Please read it. In the next chapter we will learn few more things from our IES codebook, which is limit state method. So for the first time you are entering into limit state method. There are two methods of designing. One is limit state, दूसरा है working stress method. Working stress method. So in next module I will be teaching what is the difference between this limit state and working stress in detail. No need to worry, you will be more than perfect. You will never ever leave a mark. It could be in ESC or SSC or state PSC exam. आपका कोई भी mark आपसे नहीं छीन सकता after these modules and revising whatever I have taught. Okay, have a nice day. See you in next module.